Coming up on this episode of the IoT Inc. Business Show.
What we talk about when we work with our clients is a concept we call chain of custody. And this is really a audit trail of the versions of software that touched the sensor reading all the way from the time it was in atoms until it reached the cloud and was finally stored.
We've heard it before. Garbage in, garbage out. And this is especially problematic with IoT data, where dirty data, that is, data that's well-formed but wrong, can cause a butterfly effect chain reaction, polluting the data lake, resulting in bad decisions and bad business. In this episode of the IoT Business Show, I speak with James Branigan about what bad data is, how to identify it, stop it, and then deal with the aftermath.
All this and more on this episode of the IoT Inc. Business Show. The people, the business, and the technology of the next generation internet. This is the IoT Inc. Business Show. And now, here's your host, Bruce Sinclair.
Hello and welcome to the IoT Inc. Business Show. This show is made possible by sales of my book, IoT Inc., published by McGraw-Hill, and the IoT Inc. Certified IoT Professional, or ICIP, online training and certification program. Become a certified IoT professional by completing the program's 3 courses: ICIP Technology, ICIP Business, and ICIP Strategy and Digital Transformation. Details of which can be found at www.iot-inc.com. That's www.iot-inc.com. With me today on the IoT Show is James Branigan. James is the co-founder of BrightWolf, an enterprise IoT tech and solutions provider headquartered in Durham, North Carolina. He has over 15 years of experience as an architect and developer of M2M and large-scale industrial IoT systems. James, welcome to the show.
Thanks, Bruce. Thanks for having me.
What's up with the name of the company?
Well, that's a story my co-founder and I were looking for company names where we had a clean trademark, clean website, and touched on our past in some way. And since we both went to NC State and that's where we met, that's where the wolf came from. And we decided to go with an adjective-noun naming pattern. So after making a very long list for our wives to veto, we settled on BrightWolf. And we've been doing this ever since 2008.
All right, everybody. So listen to this. You can already tell this is going to be an analytical discussion. There's no creativity. Well, I guess it's creative, but it was like more of an analytical approach than a creative approach. Although I like it. I like the sound of it, and I think it's memorable. So whatever way you guys got there.
Well, thanks. It definitely sticks in people's minds.
Yeah. And the relationship. So there's no story with the Bright Wolf itself. It's just a nice coupling of words.
No, we had done a former startup called Bad Elf. That was a hardware-based startup. So we had a pattern of doing that, but we decided we couldn't go with a negative connotation in an enterprise company as opposed to a consumer company. So.
Yeah, no, that makes sense. So what have you been working on lately with respect to IoT? Just give us an idea of some of the projects that you've been touching lately.
Yeah, so we've been working in kind of large-scale enterprise industrial space. We've done some medical projects with medical device makers that are starting to expose connected product solutions to their end customers. We've done some projects in the fluid management space where people are trying to move from a transactional business model into selling, something like fluid quality as a service. So they're really doing a business transformation play. And we've been doing, quite a bit in what I'll generally call the protein markets, where people are trying to optimize the growth of various types of animals that many of us consume.
So this is like animal farming?
Yeah, so a lot of the use cases there are around reducing the feed consumption, which can be 50% of their costs or more, as well as fuel consumption used to run all the many systems that help them run their operations. So there's quite a large opportunity for optimization of their operations in those markets.
Yeah, no, I'm all over that, but don't let my daughter hear this podcast. She's a vegan and she would crucify both of us.
All right, well, that's up to you.
The medical instrumentation is an interesting one, and the reason I think it's interesting is because while I've never worked in it, I've had students in my workshops that are in the process of developing these devices. And one of the big questions, and maybe you've got an answer for this, but one of the big questions is, where does the medical device begin and end? And I asked that question with respect to different regulations. And, so let's say you've got a surgical device and it's connected up to the internet, and that's connected up to a server farm somewhere. So when you're doing FDA, when you're trying to get your FDA approval, does that mean it's just the device itself? Does that mean it has to go through the entire back end? What are your thoughts on that?
Yeah, you have to be very careful there. And fortunately, we've got our customers are very experienced in the process of going through the FDA approvals and avoiding those gotchas. The main thing I would say is, you have to be really careful if you don't want to trigger that you're not sending any kind of identified patient data back to the cloud. Mm-hmm. Otherwise, you're definitely going to get drug into those sorts of certification and verification requirements. If you're dealing with strictly machine data for maintenance purposes and service purposes, and it's de-identified before it goes, you have a pretty good firewall argument to say there's nothing here that falls under HIPAA, right? And we're not doing any closed loop or open loop control back from the cloud, so we're not actually impacting the operations of the device. And then you can kind of firewall off certain aspects of the system and keep containment on what parts need to go through the kind of strenuous regulation and certification processes.
Now, are the issues just around PII for privacy, or are there other issues? Like if you were doing a surgical tool, you would want to make sure that it works. Now, I don't know what the definition of works is, and does it include the back end that we're talking about?
Yeah, so you get into these control loop questions, and I'll try not to get too technical, but if the cloud side of the system is causing actions to happen on the machine as part of the procedure, I think you definitely would fall into the purview. If you're also displaying visualizations to the doctors or surgeons, where they're using their brain to then make interpretations and judgments of that data, and bugs in the code that's presenting that visualization could impact it, I think you'd also have a situation where that could come into play. So there's definitely a line you need to pay attention to, and it really gets into how is the connected system being deployed and used.
Yeah, no, I think it's a new area, but I can see that it looks like there are some, I guess, rules forming, and but going back to the issue of privacy, storing PII, it has to be stored somewhere. So you're saying as long as it's not stored in the cloud, so on premise, that's okay?
Yeah, the architectures we've seen kind of becoming popular in the medical space is to have a intermediary aggregation point that lives inside the customer's data center behind their firewall.
Okay.
And it effectively strips out any PII and sends it to their EMR system.
Now, their internal data center, is that private cloud, or is that actually on-premise?
That depends on the deployment of the specific hospital's IT and infrastructure.
So it's okay to be in cloud, then, you're saying?
I guess the point I'm getting across is the cloud or not cloud for the end customer, that's their IT department's responsibility.
Okay.
Right.
Okay.
But the point is, before it leaves to the my customer's cloud, the connected product solution owners cloud, the data needs to be de-identified, or else you're going to get pulled into those regulations.
Yeah. No, that makes sense.
Does that make sense? So there is still value in the patient data, but it should stay inside. You kind of set up a demilitarized zone where you've made sure no PII leaves the organizational boundary of the hospital or the medical company providing the service to the patients.
Right, and that organizational boundary can be whatever it is, and it's their responsibility, just like it was their responsibility before implementing or
Exactly. So
deploying the tool.
you don't change the responsibilities by adding the connected product in that case.
Right.
And that makes rollout have a lot fewer hurdles to jump over. Yeah, exactly.
Yeah. All right, James. Well, why don't you tell us a little bit about yourself and your background in IoT?
Sure. So, as I mentioned earlier, went to NC State for computer and electrical engineering, then did a master's degree at Carolina in computer science, and have been working in the connected products space and the kind of, I'll say, larger software tool space for over 20 years now. Okay. I've done industrial plant floor control systems, RFID systems, in-vehicle telematics systems, avionics systems, some military, Department of Defense, condition-based maintenance, detection systems. And then since we founded BrightWolf, Patrick and I, we've been working in heavy equipment, oil and gas, transportation, energy, medical. So we're really kind of a horizontal provider across many different verticals. So we like the part that we get to learn about many other people's businesses in depth. So that really is what's exciting for us, is learning about their business and helping people make a difference in their bottom line using this technology.
Now, I asked this because I like the variation in answers, and it sounds like you're definitely qualified to answer it. But what would you say is the difference between M2M and IoT?
Beyond the marketing is much
That's what I'm asking.
More sexy with IoT. For me, M2M was really, as a trend, was about the connectivity.
Between what and what, though?
It almost didn't matter, but it was very frequently used by the cellular companies as a meaning for a cellular-based meter data connection. Okay. IoT really, to me, is about the data more than the connection. Yeah. Right? It's about how do you derive value from the data, and based on the insights that you gain from that data, what transformations can you make, either in your own personal life on the consumer side or in the enterprise side to the bottom line. Whereas MDM was really more of an enabling kind of phase, where you said, if we can connect this, then maybe we can do something. And IoT to me is really more about the transformational power of the data.
Yeah, I think we're kindred spirits. I'm liking your approach because, yeah, I agree. I mean, all incremental value from an IoT product comes from transforming its data into useful information. I mean, it really comes down to just that. And it's true. M2M, I think, is more of that connectivity. And I have kind of a pet peeve with respect to calling products connected products, versus IoT products because of that one reason is that IoT isn't about just a connectivity. I mean, if you're utilizing the whole internet, and there's a lot more to the internet than just a connectivity.
Absolutely. Yeah.
So today we're going to talk a little bit we're going to get down and dirty, and we're going to talk about dirty data. And this is a topic that we haven't discussed yet. And maybe just give us some broad strokes about this, James. What is dirty data in the first place? And just frame the beginning of the conversation.
Yeah, so dirty data is well-formed data reported by your devices.
Yep, looks good.
That is invalid in some way. So it doesn't immediately get flagged as, this is garbage that we can't even interpret. You can totally read it in, but you find out at some point that data is actually completely invalid. And the reason it's a problem is because in all these IoT systems, as you look for value in the data and you make programmatic analytics that are going to run over those incoming data values, you're going to connect those analytical outputs to your enterprise system in some way. You might dispatch a service tech. You might send a replacement unit to somebody. There's some interesting event that's going to happen as the output of all of this. And if you base that interesting event on bad assumptions, dirty data that came in, you get into this classic garbage in, garbage out problem that's been known about in computer science for a very long time. But with these automated systems, as they come online, you have the opportunity where dirty data could cause you real harm, where you're starting to incur real economic cost because these automated actions are being kicked off by data that is not actually valid.
Yeah, and I think you bring up a good point, is that the automated being one of the key words here, because we've been doing big data analysis in business, other sources of data for a long time. So what do you see as the difference here between that and IoT?
Yeah, I think it's volume and velocity are really the fundamental differences. You know, the three V's I like to talk about IoT data are variety, volume, and velocity. But compared with the big data analysis, there's a lot of data cleaning tools in the big data marketplace.
Yeah.
And those are really centered around you're a data scientist. You get a fairly static data set. You need to go through and clean it, and then you can analyze it looking for something interesting. And that approach really works well with data generated by humans, right? At the rate that humans generate data, at the rate that machines generate data, that approach doesn't scale. It's not even possible. So you end up having these ingestion systems that are taking live feeds from the devices, streaming analytics over them, and then hooking those outputs up to some enterprise system so an action happens automatically. So you really have to get into the mindset of we need to be able to clean this data on the fly, not during a step in the big data analysis pipeline where there's a human in the loop today.
Now, in that big data analysis pipeline, what does cleaning the data mean exactly?
It can mean different things to different folks, but based on the data set. But it might be looking for outliers in a signal, right? It might be adjusting, for certain demographic trends. If someone was doing a census-based analysis, there's many different things that data scientists study around techniques to try to remove bias or error from the data. But with machines generating the data, there's whole new classes of dirtiness that can happen beyond human-generated data, and that's really what the focus of cleaning your dirty data really needs to be. Or where the focus needs to be drawn is to those points.
Yeah, and I think you bring up something important, and let me see if I can paraphrase it. The error fixing or the data cleaning that we're talking about on human-derived data, although it may not all be human, but let's say that, is going to be logical errors? Is that a fair way to, logical, how you approached it in the first place and how you classified it, whereas we're not, I guess it's maybe that's a subset of what we're talking about for IoT. Is that a good way to look at it?
Yeah, or if you were doing like a climate data set, right, it might be how was that data captured, right? So the data that was captured in the 1950s may have used a different thermometer technique than is used now, but that technique is known and it's adjusted for one time in the data set, and then someone can continue on with their analysis.
It's like a normalization or something like that.
Exactly. And so with all the different device types and the speed of the data going by, that's where this becomes a problem that you can't just bring one human in the loop and fix anymore.
Yeah. So what are the sources of data that you're finding? What are the sources of error that you're finding in IoT data?
Yeah. So there's really I call them kind of four main areas, and for the dirty data, I want to focus on this fourth area. You can have time errors, you can have identity errors, and you can have trust errors. And what that means, and for those three that we really aren't going to focus on much, are you don't have a good time when this event happened. So an event happened, but you can't place it in time because the clock was wrong. Then there's ones where you don't actually associate the event with the proper device for some reason because it's lost an idea of who it is, right?
Yep.
We've all had Bluetooth devices, lose their pairing and we have to repair them. But imagine that happening where you're actually getting a report in from a device where you don't know where to stash the data. And then there's trust issues where someone's actually attacking you or trying to impersonate a device. Those are all different sources of error, but they're not the same as what I call dirty data. So for dirty data, I really focus on these kind of three different categories. One is there's something physically wrong with the sensing mechanism itself, with the sensor. Either the environment's changed or the sensor is having an error that it cannot detect itself and is giving you well-formed but completely garbage data.
And when you say sensor, you mean the transducer, the actual sensing
Yes,
component.
where atoms meet bits. Exactly.
Okay.
Right at that interface. The next kind of category is, I'll call it firmware, but what I really mean is software that runs on the device, right? The embedded electronics component of the product. That can have software bugs.
Sure.
And software bugs can vary based on the level of firmware or software that's installed, and again, cause different types of issues where well-formed data is reported in that is totally erroneous. And then the third category, which is really nefarious, is where you need very specific knowledge of the machine operations in order to understand how to interpret the data that comes in. And without that knowledge, you may interpret a data packet as valid when some other part of the system did not intend it to be interpreted that way.
Okay. Well, so there's kind of a bit of a crossover here because as we know, we've got a few different layers of standardization or of protocols, and one of them is the application protocol, and the purpose of the application protocol is to contextualize the data. And so
Absolutely.
The sources, earlier you were saying when and device, that's contextual information. Then you got into the nefarious, the trust issue, and it's like, oh, okay, well, that's different. But now here, the specific knowledge, you're again talking about contextualization. So is this again a kind of a logical error where you didn't use the right application protocol, or you didn't design the fields within the protocol properly, or is it something different that you're talking about?
I answer that first part of the question about design it properly with the idea or the philosophy that it's impossible to know the future requirements.
Mm-hmm.
And so even if you design it perfectly today, the future requirements may change. And so let me give you an example that we've encountered in the field about this. A protocol, application level protocol, was designed between the device and a cloud-based back end of the system. And it was working well, and all the fields were flowing across, and everything was fine. And then in the field trials, it became evident that the battery backup for the device that the device ran off of most of the time was running out of power too quickly.
Okay.
Right? So what the decision made by product management was, let's see if we can power down some of the subsystems we don't need at certain times.
Yeah.
Right? And it's a very reasonable product management decision to make and ask engineering to investigate in order to make the product acceptable in the market.
Yeah. Mm-hmm.
What happens as a result there is you have a protocol designed where now the reports that come in are going to have data values that are invalid at certain windows of time based on if all those components are powered up and reporting, or if they're stuffed with filler values.
Yeah.
Right? And so now you've got a situation where in the cloud, we've received this data and we may have been streaming it to analytic engines and all over the place to AI to do interesting things. And those systems were developed not aware that sometimes this data was going to be invalid. So you really get into life cycle issues where it's impossible to define upfront the perfect protocol that is going to work for the entire lifespan of the device.
So, I mean, is there, I don't want to get into solutions too deeply, but it's just too seductive not to ask, but I see what you're saying. What you're saying effectively is that you're going to design, the contextual information in such a way that makes sense for that point in time.
Yep.
Now, these are extendable, aren't they? So is it kind of like you just have to then extend it and then just take note of that in your analytics? Because, you want to add that extra context of whether it's on or off, and then whether or not to look at the data. So what's the general approach when you're in this kind of general problem?
Yeah, so someone at some portion in the chain needs to be aware of the context of that, right? That in this situation, those values are not valid, right? And there's two approaches. One is you can make every possible consumer have to be aware of the application-specific gotchas, right? Where the device data may not be good. Or you can centralize access to the data and put the control point there to say, we're going to write this application logic that knows this one time, and then all the systems downstream of that centralized location will pull data that is known to be good without having to be aware of the application-specific concerns that the product manager had to make.
Right? I'm not really liking either of those solutions. I mean, the first one it kind of defeats the purpose of the application protocol, and then the second one adds an extra layer of indirection. So you've got a translation of the protocol. Can't you just extend it in some way and and update the applications that are going to be consuming it?
You cannot, in IoT generally, you cannot assume that you can ever force update a device in the field. You hope that you can cause it to upgrade its software, but we have consumer-based devices where the consumer has to be involved in doing a specific key sequence with the ignition in order to get the device into a mode where it can update the firmware, right? In that situation, we cannot force any of those end users of that product to update their firmware. So when firmware goes out in the field, we may be stuck with that firmware forever.
Okay, right? So if you could update the firmware, is the extension, for everyone listening, I'm just trying to, work through the different solutions. Yep. Is the extension possible then if you can update the firmware?
Absolutely. So if you can improve your protocol, you should improve your protocol.
Yeah,
but
right.
For many, many IoT products, especially those maybe that go through FDA regulation like we talked about before, there's going to be an approved version, and that's going to be out there for a long time.
Yeah.
And you may have to deal with that approved version for many, many years, right? So you need techniques that work and don't just solely depend on updating the software, although that's awesome if you can do that.
And to me, that seems to be a best practice in the sense of just making sure you've got an OTA mechanism in your product, because not only that, but you've got security issues that you want to update periodically. You want to add new features. So, to me, that's almost table stakes that you want to have it, but I guess maybe that's just not realistic in some circumstances.
Well, it's table stakes that you absolutely need that capability, but the ability to force it should not be assumed. So we have a refrigerated trailer client. Firmware updates cannot happen when the unit is on, period, right? Because it actually does local control of the temperature of the zones of that refrigerated trailer. So if the unit's on, we have to assume it's loaded.
Yeah.
Right. Yeah. So there's constraints on when and how you can update firmwares that are very business and application specific. So you should absolutely have the capability, but whether you can exercise it to upgrade everything to the same version in a timely manner is really a application specific issue.
Okay. So the motto of the story is if possible, yes. You want to put OTA in there, and then at some point, you're going to have the ability to upgrade it. But you can't, if you can't do that for whatever reason, maybe it's because of regulation issues, maybe it's something even more complicated than the refrigerated truck where you just no longer have access for some reason, then you may have to choose one of these other two solutions. Both of them are kind of ugly, but at least there's kind of a way to do it.
Yes, exactly. Yep.
Yeah. Okay. All right. So we said something, so this makes sense. So there's something physically wrong. There's something wrong with the physics, of the sensor. Yep. Right? We've got something wrong with the logic in the firmware, and we have this issue of, I guess, this contextualization issue, or this problem in the change of the data that wasn't captured. Is that a good way to kind of encapsulate what we talked about?
Yeah, absolutely. Missing context is a huge portion of the problems, because many protocols don't capture all the possible context, and so that is very often part of the problem is the consumer doesn't share the same context with the producer of the data.
Yeah. Now, well, I guess we're going to dig into it a little bit. So you kind of opened it up. So the protocol doesn't support it. Now, most of the application protocols, whether they're CoAP or they're DDS or, pick it. I know there's a couple different architectures, but aren't they all extensible? Maybe provide a little bit more color there.
Yeah. So, whatever you choose, from a standards layer, at some point you start deciding what specific elements to your application you're going to include, right? And that's really what I'm getting at. It's not that they're not extensible. It's that you have to do the extending.
You didn't design it fully for whatever reason at the beginning,
right? Or someone makes a change somewhere in the chain that doesn't realize that impacts the protocol.
Yeah.
Right?
Yeah.
So this could be something as simple as, the units that you're going to report the data value in, right? To give a really easy to understand example, if it's a temperature, do I report it in Fahrenheit or Celsius or Kelvin? And, what's the resolution of that data? And am I reporting the raw value that came in from the digital converter, or am I reporting already transformed version? All of that context needs to flow in some way to the consumers, or it needs to be turned into some metadata that they have access to on their side if it doesn't flow through the protocol.
Yeah, and just to be clear to everyone, consumers, what James is referring to, I believe anyway, is going to be the consumers of the data. So that'll
Exactly.
be, some sort of application. The producers will be the sensors or some external system that you're connecting to.
Yep, that's exactly right, Bruce. Thanks for clarifying.
Now, I guess, that it's a bit worrisome because we've got these three issues. I mean, other than it hitting you in the face when you're doing some sort of visualization, how do you know that how do you know there's some ghosts in the machine in the first place? I mean, is it just knowing your data, or what do you do?
Yeah, so there's really kind of three techniques we've seen folks use, and I'll go through them in the order that you hope to be able to catch the issue in. The first one is to have an idealized model of your device.
Yeah.
And this can either be built up statistically based on normal operations, or built up in code where someone says it should generally behave like this.
Like a state machine maybe,
exactly,
or something.
Exactly, yeah. And so you compare the incoming data to that idealized model and see if it's within range, right? And if it's not necessarily an error, but it's something that you might want to flag for your engineering team to look into, right? The next tier is what we kind of call reasonability alarms internally. And what that means is, like say we have the tractor trailer example again. One way to detect an error in the GPS location reports is to try to calculate the distance between those reports and speed on the time, right?
I like it, yeah.
And so if the distance between those two positions goes faster than a tractor trailer can reasonably drive, then you very likely have a data problem. And so across many different sensor types, there are different types of reasonability alarms based on the physics of the sensor or the behavior of the device that you can put in place to kind of help you check as you get a large population, is anything behaving weirdly?
Okay.
We've had in the tractor trailer, for example, we had guys with slightly loose antenna cables to the GPS antenna. So they would get a lock when they were sitting still, but when they got up to a high speed, sometimes it would shake loose and we'd occasionally get a 0-0 report. Right,
yeah.
Jump to the middle of the ocean. And so those sorts of reasonability alarms can let you know, oh, there's something going on there. We may need to have somebody look at this and take the right action. And then the third and least desirable way to find out about it is actually through customer error reports, where the customer notices something is weird in the system, like say the tractor trailer driver or owner of the fleet logs in and says, wait a minute, why is my trailer in the ocean? That makes no sense. What's wrong with your software?
That's embarrassing too.
Super embarrassing, yeah. And the worst thing is it causes users to lose trust in the system, and they may stop using the system as a result. And if your business model is based on the users trusting and using the system, dirty data can have a real impact there. So it's really important to try to catch it before your customer is telling you about it.
Yeah, and now catching it, I mean, so modeling the device, all right, well, again, this is, I'm a big, I mean, that's the central to everything are the models, and this is just yet another one. So modeling it and interrogating that model, just making sure things are statistically going according to the model, right? I mean, and so this is going to be, I presume it's going to be some sort of a post-analysis, or is this possibly something that's executed in the stream?
No, what you hope to do is maybe during your field trials, you're building up the set of data that you're going to use to build that model of what normal looks like. And then you hope to put it into the processing pipeline, not do it after the fact.
Okay. So it's quick enough. And this, again, will be some sort of, anomaly detection on the model that you could do in real time?
Yeah, you don't necessarily want to take action, but you want to flag it as it goes by.
Okay.
Right? Okay. And then you have... because you need someone to investigate it who is aware of the application and can dig in and say, no, I think that actually looks normal in that situation. Maybe they were just going faster because they were going downhill or something beyond, and we had tightened the bounds too tight on the speed. Let's back that off a little bit. So you don't necessarily want to throw out the customer's data just because it triggers these, but you do want to investigate it. And after the initial kind of beginning rollout where you capture the variance of usage in the field, you usually don't have to tweak these too much. So you'll be pretty busy with them for a little while, and then they'll
at the beginning,
they'll kind of get built up, and you'll be happy with them.
Now, the second one, the reasonability, I think that's what you call the reasonability analysis, or maybe something slightly different. That's some sort of a logic model again. So just you're creating some logic, you're putting it through the logic. That's something you should be able to stream. And I guess it would serve the same purpose. It would just raise flags and then for future analysis, or do you handle that differently?
Yeah, these are things you can use that. The way we use this is almost like a backstop. So if the idealized model doesn't have enough data yet, or we didn't have a dimension in there that we were capturing, there's certain things that if you know about the device at design time, you just know it's never going to do this normally. If we get data that falls into some pattern, this is clearly a digital data problem, dirty data, not some problem with the device actually going past the speed of light. And so you want to put those kind of checks in as a backstop. And that helps you also catch stuff during the field trials before you have found or built up enough data to build the idealized model.
Yeah, no, that makes sense. Now, I guess this is a bit concerning. How big of a problem is this? I mean, how often does this happen? So everyone's listening now and they're thinking to themselves, "Oh, geez, all right, well, we don't think we have any problems, but." Is this a problem that everybody should be jumping on right now? Just give us some idea of how frequently you're finding it, and how big of how important of a problem it is.
Yeah. So the first thing I'll say is, if you're not measuring it, you're not going to know you're having it until your customers report the problem to you.
Yeah.
And that could be very embarrassing or have been very expensive by the time you find it.
Right.
So
you'll be on the hook for that, right? I mean, it's not
somebody
like
will be.
Yeah.
It's very important to do the measuring. We've been measuring, many of the different customer projects we work with for a very long time. The incidence rate we're seeing is about 1% per firmware and board design combination per month. So over a lifespan of a system that's 10 to 15 years in the field, it's very likely that every product will have some sort of issue during that time. And they may have multiple issues depending on the quality of the software team, which tend to be the more common source of the error. So it's something that's going to happen. It should be viewed as a certainty. It's going to be unpredictable when it will specifically happen to your product.
So you're saying within a window of, let's say, 15 years, 100% certainty. I've had the system out there for 1 year. I don't know if we can even do the math on that, but I think it's more of a gut thing or an experience thing. What do you, 1 or 2 years?
Breaking out Excel, I would say it's probably in the 5-ish% range.
Okay.
But most of the bad behavior of the system is going to get wrung out in the first year. Right? It's in the later years, it's issues due to changes in the product. Or changes in the board designs, right? As you need to rev products due to microprocessor parts going out of stock.
Yeah.
You're still shipping it and you've changed something and that impacted the firmware in some way. It's those sorts of subtle issues that sneak in once a product is baked. So I would say for the long-lived ones, it's about 1% a month if something happens. For the initial field trials, it's going to be much higher. But you have a lower population and you probably haven't hooked it up to enterprise systems at that stage yet, so your actual cost per incident is probably much lower in the field trial stage. So that's when you want to find these.
Yeah, no, but even if it is, let's say it is that 5%, I'm just, 1 in 20, trying to get just a gut feel for it. It's an issue because of the ramifications of it, and
absolutely,
and so it can be a big problem. But some of this, I guess, is out of our control because you're talking about this combination of board and software, so hardware and software. Yes, I can see the firmware being, if we have that OTA, I can see the firmware being changed. The hardware too, I guess over a long period of time, you may use a different board set for a particular sensor. Is that kind of, talk a little bit more, give us a little bit more detail on this board firmware interplay here.
Yeah, so those of you listeners that have done long-lived products before, that parts go out of stock and you have to redesign boards and you do your best to try to keep things pin compatible, but sometimes stuff happens.
Yeah.
Right. And so many times you're trying to use a very similar firmware image on the microprocessor talking to modules that are supposed to be pin compatible, but they actually behave a little bit different. right, and introduce subtle errors. And so that's really the part that comes in with the board combination.
Yeah, right.
Are those sort of product management lifecycle issues, and how you're going to track those, down the line.
Mm-hmm, mm-hmm. And the firmware ones, however, that would be more common, again, assuming we are updating our firmware, and to a certain extent out of our control. We're assuming that there's going to be this QA is going to be done by the board manufacturer, by your partner, your embedded partner. But is that kind of the deal?
Yeah, you definitely want to run through, for every firmware version, do not go straight to production with it, right?
Yeah,
run it through some tests. It's obviously
you're going to have
practice.
A test bed, yeah,
yep.
Right.
And then see how it behaves, and if it's continuing to behave according to your idealized model, and you're not triggering any of the alarms, you start a phased rollout to that firmware version, and then eventually get it out there. A big part of what you want to do with this combos of the board design and the firmware is you're looking for population analysis when you do detect dirty data. So you want to see how big of a problem is this, right? Say I had 100,000 devices out with firmware version 6, but 10,000 of them are on the new board level, and they're the ones that are having the dirty data. I really want to only, cause the firmware updates to those 10,000, especially if I'm on a cellular connection that's metered.
Yes, right.
So, and in the medical space, where recalls can be mandated and can require people to go on site to update the software potentially if firmware is update over the air isn't allowed by the end customer, which can often be the case in a medical environment. You end up having these costs associated with the upgrade, and you want to see what's the impact. So you really want to track your dirty data incidents across these dimensions so you can determine how big is this problem.
And that implies then, if you are tracking it and you're being able to isolate these populations from the others, that implies then that your update mechanism's also going to have that fidelity.
Absolutely.
That you could, and so that's, I guess, something you need to think about. And this sounds like another best practice to me is think about that during your OTA design.
Yeah, and that's another bit of context, right? So there's all these bits of metadata and context that matter in scenario-specific situations that the person making the application protocol may not think about. They may be thinking about, how do I get these temperatures and pressures up to the cloud, not how do I get the sub-serial numbers for the BOM of this board up to the cloud so that somebody can implement a recall scenario eventually.
Yeah, which you need to do. Yeah,
exactly.
Which makes a lot of sense.
It falls onto product management in a lot of cases to properly collect the requirements from all the different stakeholders, right? And that includes the folks that have to manage the system over its long lifespan, not just the folks that are going to be the end users and the support team.
Yeah, so during the requirements phase, just what we're talking about right now, the OTA mechanism has to be really concerned and make sure that those requirements are in there right from the very beginning.
Absolutely. And all the data, all the audit trail and breadcrumbs you need to support having that capability to do the recalls or take the mitigations.
All right, so we're listening now, and we're hearing. All right, yeah, no, this makes sense. There are a number of different forms of dirty data. They're happening with varying frequency. What do we do, James? So how do we mitigate this, and how do we fix it if it's happened already?
Yep, yeah. So there's two parts. One is you're going to at the event, whichever way you detected it, that you realize you have dirty data. You're going to have two problems. One is you still have data coming in from devices that is dirty right now, every single second. And you also have all this data you've already collected that may be polluting your data lake, right? And then you're running analytics on that are generating bad outputs. So you really need to figure out, how do we clean this dirtiness from the data lake? And how do we prevent new dirtiness? How do we filter it before it gets in there? Right. And so the techniques you need to use are a little bit different there. On the preventing the new dirtiness from getting in, the best thing to do is have an extensible data processing pipeline where you have the ability to plug in these data cleaners that filter on those dimensions of the firmware board combo. So you need access to that kind of metadata information about the device even if it's not in the protocol, you need access in the processing pipeline to say, hey, version 13 of the board with version 8 of the firmware has this known bug. So if a device reports in that is currently running that, I need to apply this cleaner, right? And I need to check for this condition and filter out that dirty data.
Okay, so while we're in the stream, before we get to the lake, give a little bit more detail around the data processing pipeline.
Yeah, so
what it is, and just in general.
Absolutely. If you go look at some of the large cloud providers, they provide IoT primitives around data ingest, standards based around MQTT and some HTTP and a few other protocols. That ingest needs to go somewhere, right? And that somewhere in their architecture diagrams is just labeled application, right? And that's up to you to provide. There's a number of folks that provide platforms for helping you manage the storage and data management of the data. And we're one of those companies. But at some point, you need to get that data and you need to get it stored. And before you get it stored, you need the ability to analyze that data, right? Or you need the ability to store the data, but before you actually make it available to the consumers of the data, have an opportunity to decide if you trust it or not. Basically, make a distinction. Is this clean data or is this dirty data? And if it's dirty data, you may want to put it aside for analysts and engineers to look at. So you don't want to throw it away, but you just don't want to make it available to your main part of your processing pipeline.
So pool it. So this is important, everyone. What James is saying is that it's not necessarily before the uptake, before you bring it into the cloud. It's in the cloud, and then before you actually save it in the database and in any particular way, you're looking at it. You're maybe running some logic on it. So this implies, I think an important point is it implies this doesn't have to necessarily happen in quote unquote real time, right? I mean, this is happening after it's been ingested, and then there's going to be some post-processing that's going to happen to it, or maybe nothing would happen to it, but at least it's going to be looked over before it's actually stored in a database somewhere.
Yeah, our best practices is that we recommend to our clients. We store the raw communications exactly as they came in.
Okay, right.
Because we want to save them just in case something were to happen. Then we have the data kind of parsed and atomized, normalized, and contextualized, but it's still in an untrusted state. So it's only available to these cleaning algorithms at this stage.
Okay.
Right? So it's stored, it's persisted. We're not worried about something crashing and us losing data, but it's not available to an algorithm that's going to compute something that kicks off an enterprise action. Right. And so then the cleaners run over the data, and they essentially, their entire job is to make a decision of, do I trust this or not? And they have a lot of context available to them when they run about the device and the software it's running, et cetera. And they make that distinction, right? And then that device, if it gets marked as, yes, I trust this right now, it gets put into the data store that is available for the consumers.
Got it. So you're creating a separate pool effectively and storing the raw data, which makes a lot of sense. You'll keep it for whatever period of time makes sense to your business, and then you're putting it through these cleaners. And the cleaners, I guess, whatever that definition is, can be pretty broad, but some of it is going to be what we're talking about here.
Exactly. So it might compare with that idealized model, right? That would be a type of cleaner. It might be the reasonability limit checker, right? Would be a type of cleaner. And it might be specific rules that you put in place based on finding previous dirty data conditions, like the example I was giving with the specific firmware and board version, and you're looking for those conditions on a specific device, and then you're going to further dig into the data and decide if you trust that specific data or not, and then mark it, clean or dirty appropriately.
Okay, so for the stream of data that's coming in, the best practice is pool it first, scrub it, and then put it into whatever lake, or I guess whatever lake or whatever store that you're going to eventually use it. Is that the extent of curing the inflow of this bad data? Yeah,
that's how you stop it from the problem from getting worse.
Okay, from more pollution.
Exactly.
I like the polluting analogy. Okay, so let's talk about the data lake, the polluted data lake. Now you've got, unfortunately, some of it hasn't been cleaned properly, and so you've got a bit of pollution in that lake. What do you do?
Yeah, so in many cases, if you did not architect the data to keep the right metadata and breadcrumbs around, you won't be able to do anything, because you won't know, without having left the right breadcrumbs, you won't know what board version and software version were used to collect this data at this point in time.
Okay. What is a breadcrumb?
So a breadcrumb is it's just a different type of context. It might be used usually not in the normal access way. It's used to help support these specific scenarios where you're going back and you need to look through data and figure out the state of the world at the time that data was reported, so that you can say, oh, I've now detected this pattern on firmware 8 and board 13. What other data came in from devices running that in the past? So that you can do these kind of administrative queries and say, ooh, this, I found now a set of data that matches that. So if you've ever set up your Gmail filters, right, you can say, apply this filter to past conversations, and it searches through your email to see what matches that query, right? Yeah. It's a very similar thing that needs to happen in the data lake to say, we've now found a dirty data pattern. I need to have enough breadcrumbs in there that I can run a query to find what other devices might be susceptible to this. And now I can post-process that and take some of that data out, mark that it's trusted false, right, and remove it from the data lake.
So this is kind of like forensic data, contextual data that you're adding. And okay, I get that at a high level. I get that concept. But what is it beyond storing, for example, the serial number of the board or the update of the firmware? Give us some, if you can anyway, give us some examples of these milestone markers of data that are there strictly to help guide you through it if you need to go through it in this way.
Yeah, so what we talk about is when we work with our clients is a concept we call chain of custody. And this is really a audit trail of the versions of software that touched the sensor reading all the way from the time it was in atoms until it reached the cloud and was finally stored.
Jeez, okay.
And that allows us across many different processing stages to determine where an error was introduced and then to find the other cases where that data may have happened. So we keep a complete kind of audit trail for governance purposes of where did this data come from, so that we can clean it later and determine the impact later if we determine that there is an error. So there's quite a lot of bookkeeping that you need to do about the data in order to be able to support these sorts of cleaning scenarios.
But again, we're talking really about putting context around it, around the data itself.
Absolutely.
Just in terms of where it came, everything about it. And so that we can then go back and, all right, so that makes sense. So if you have stored this, and so for everyone listening, again, no, this is stored in that application protocol that James was talking about earlier. And this comes back to the design of, how you're going to extend it and how you're going to design it. So this then again wraps way back to the requirements, which of course is probably the most important most important best practice here is to be thinking about these things right from the very beginning. Right?
Absolutely.
So we've got pollution, we have breadcrumbs, and we've been able to identify. We've been able to identify the parts of the lake that are polluted. What's the next step?
Yeah. So now we've identified all the source data that was based on that erroneous report, right? So we got a message that came in the protocol and it all got stored as trusted at the time. We found out it was untrusted later, and we've now are able to remove it. Well, part of removing that is saying people may have computed things based on this sensor already.
Right.
So
it's a chain effect, yeah.
Yeah, it's a chain effect, and those calculations may or may not be impacted in significant ways. And so this is specifically why we recommend the chain of custody as a best practice approach, because it gives you the ability to know for that new algorithm output that was based on that input, its chain of custody includes that data point that was known to be untrusted now. And so now you can either reevaluate that or mark that output untrusted. And so, by iteratively going through this process, you can clean your data lake of data that was generated based on erroneous, dirty data coming in.
And I'm trying to get my head around this because when you're basically talking about a chain reaction in a sense. So
I am, yes,
right?
exactly.
Yeah. So you've got this dirty data. And if it's used in calculations, it's going to affect other data, and that data is going to affect other data.
Yeah, it's very much the butterfly flapping its wings that causes a hurricane on the other side of the ocean. Yeah.
But you're saying, okay, but as long as you have those breadcrumbs in there each time, so this implies then during those calculations, you need to maintain that contextual data.
Absolutely.
And you need to and you need to maintain those breadcrumbs so that you can still, it doesn't matter at the end of the day, and even then, if you have it, you can search it in different ways. But as long as, again, you're smart up front in the design of your application protocol, right? Then you should be able to then find this dirtiness in the lake and then do something with it, I suppose, right? You've now identified it very clearly and you're filtering it. I guess, right? I mean, at this point, it's just going to be really domain specific or use case specific.
Yeah, absolutely. And it gets very much into the application needs and the behavior that dictate what you need to do. But our best practices are around giving you a framework for iteratively cleaning the data, regardless of the application-specific nature of the dirtiness. So it's really around, how do we help you help yourself later on when this problem strikes you?
Yeah, no, this is very important, very important. And again, the message here is this is something that has to be thought of right at the very beginning, because theoretically you could potentially retrofit, but it's not just retrofitting this. Now it's retrofitting your recipes and your analytics. It's retrofitting a whole bunch of different things, not just this firmware that we talked about that could be potentially done with an OTA update.
It's certainly easier at the beginning. Folks that do have existing protocols that they're trying to enable, for those folks, you can add the additional context out of band, but it doesn't flow with the protocol now. So now you have management risks around making sure that out of band update of the context that you need and the breadcrumb stays current. But it is possible with more less greenfield and more brownfield type deployments as well.
Yeah, and again, I think what you're doing is you're just having to add these extra levels of indirection where you're doing some sort of processing. It's possible, and again, it's not doomsday if you do find this problem. But I think the motto of the story here is plan for it at the beginning.
Yep, absolutely.
All right, so besides, this is awesome. So we have an understanding of the streaming data. We have an understanding of how to clean the streaming data, clean the data that's been pooled in the lake. Anything else you want to add to, I guess, fixing the problem issue?
No, once you've got there, you've resolved this specific instance of dirty data. The thing we would then recommend to our customers generally is do an analysis of that failure mode, right? And try to see how did that error sneak in, right? This is just good engineering practice to do retrospectives, because you may find during that there are 3 other ones that you haven't found yet in the field, right? That are susceptible to that exact same pattern. And you can go ahead and get the cleaner to stop the data coming in sooner and save yourself a lot of work down the line, or letting your customers find it. You can find the issue instead.
Yeah, no, it makes sense. Now, one thing you haven't talked about other than indirectly has been the QA process. I mean, we've talked about our test network and, deploying changes there first within a small field trial, but I'm assuming there's some best practices around and doing the measurement. I'm assuming there's some best practices around the QA methodology, or is it just standard QA that we're talking about here?
Yeah, so the from the cloud side, for that portion of the processing where it could inject errors, we recommend using a simulated device approach, because you can really test the full range of data values that the application protocol could create. And some of those may be very challenging for the device to actually get the physical device to generate, right? Or maybe destructive for it, for example.
And there's lots of machines these instruments, these testing machines, right, that will supply this type of data, I suppose.
Absolutely. Yep. And so we recommend a simulator approach for sure for the cloud portion. For the device portion, you really need to at least take a couple of your devices through the full range of the error suites and make sure that the software detects them and reports them the way that you hope, right, for the operating ranges, and even take them outside their operating ranges. So this is just good old-fashioned QA at the embedded product level. The new bit for those folks who've never connected anything is you have to kind of desk check that the protocol reports that were generated in those error scenarios actually make sense This really requires a person to say, okay, so we did that scenario and it was within our expected behavior physically for the device, but did it report in what it actually experienced, or did it report in something strange? And so that's the bit where QA teams that are used to doing non-connected embedded products have to adjust their practices a little bit.
Yeah. A little roll up the sleeves a little bit and use the gut and just examine it.
Yep.
James, that was very helpful. I appreciate you shining that bright light on this particular problem, one that I guess we haven't really talked about on the show up until this point in time.
Sure.
Let our listeners know a little bit more about you, your company, what it does, and where we can find you guys.
Yeah, so the company name again is BrightWolf. You can find us on the web at brightwolf.com. We also are on Twitter, bright_wolf as our handle. Okay. We are a software company based in Durham, North Carolina. We help the Fortune 1000 size companies and those that serve them develop their IoT-based products. So we work in kind of the enterprise industrial space. We do have a platform that helps with all the cleaning data and dirty data issues and many other things that we did not talk about today. And then we help the clients through services. If they don't have their own development teams, we can help them build their applications with their product management and marketing staff.
And we've been kind of talking most of the interview about discrete products. It seems like anyway. Is this as applicable and as BrightWolf as applicable to more of a system IoT? Bringing it in to a manufacturing line, for example, or as opposed to medical device, which is kind of more of a discrete system. Yeah. Is everything we've talked about pretty much the same? And what you guys or do you focus on one area more than the other?
We focus more on the connected products, but we do have some process-oriented folks as well, like a manufacturing one. The difference, I'll say, to answer it generically and not about BrightWolf, is if you're doing the manufacturing process side, you're going to have a lot more variety of devices. Yeah. But you're going to have a lot less variance of use.
So because it's more constrained.
Yeah,
right?
you kind of trade one variable for the other. So you still have the problem, but it's going to get pushed more on the variety of devices. Whereas if you're offering a single product type, what happens there is you don't know how your end consumers are going to use it. So the usage patterns vary widely, and that's where you can get your variance of figuring out these dirty data situations.
Yeah, no, that makes a lot of sense. All right, everyone. So I'll put the information about BrightWolf in the show analysis notes, so you don't have to write it down. And with that, James, thanks.
Thanks, Bruce.
That was fun.
Yeah, it's been great. Thanks for having me.
Good job, man. That was great. I enjoyed that. I learned a lot. And I think, it really shows what's important here is you expose a lot of, I guess, the realities of actually implementing a system. You can talk about it. There's a lot of pundits that talk about this, but by this particular issue, it uncovers a lot of implementation issues that this is stuff you only learn by doing. And I'm sure that's come across in the show. So
I hope so. Yeah. I appreciate you letting us get in front of your audience. It's really a good way for us to get some exposure and show people our expertise that we've actually done this many times before.
Yeah, no, and I think it's important, and sometimes I worry that we get into it too much for the advanced person. But I think in this particular case, I think even if you're not that far along, it sends the message that you need to think about this right from the very beginning. And I think we gave some good actionable steps. So good stuff.
Great. Thanks.
Yeah. We'll put it together, and it's probably going to be still a few weeks out because my cadence has been really slow. I'm only doing them every 2 weeks right now because I'm super busy on the book, finalizing my book. But I will let you and Mark know, and then we'll start marketing the hell out of it.
Awesome. Sounds good. Thanks, Bruce.
All right. Thanks.
Yeah. Have a good day. Bye.
Okay. That was a real informative talk with James Branigan. This podcast goes vertical, deep diving into different topics each week. If you prefer a more horizontal and structured approach to learning IoT business and its orbiting technologies, check out my book IoT Inc., published by McGraw-Hill, or become a certified IoT professional by completing the ICIP training and certification program. For details, just go to www.iot-inc.com. Also go to www.iot-inc.com for an analysis of this episode, links to things that were mentioned during the episode, and very importantly, the episode's PDF transcript. Just search for the name of the episode or the guest. If you're new to this podcast, subscribe. That way you'll get every week's episode delivered straight to your device. Or, if you've been listening for a while, there are 3 ways you can support the show. You can leave a rating or a review on iTunes. Just go to iot-inc.com/iTunes. It only takes 1 click to leave a rating, a little bit longer to leave a review. You can share it on social. I'm on LinkedIn, to a lesser extent on Twitter. And of course, you can support the show by buying my book, IoT Inc., or the ICIP training and certification program. It's how I pay the bills. Next week's episode is Wrangling Data from the Data Marketplace with Adam Meyer of Click. I hope you can join me then. I'm your host, Bruce Sinclair. Thank you for listening. Until next week, may your path to IoT business be a clean one.
You have been listening to the IoT Inc. Business Show.